Dear students, I am Dr. Ashok Kumar Saini, Associate Professor in Mathematics in BLJS College, Tosham. Today I will deliver lecture on number theory and trigonometry for the students of BA, BSc, first year, semester 2nd. The topic of lecture is inverse trigonometric, inverse circular and inverse hyperbolic functions. So inverse circular and inverse hyperbolic functions, chapter 11 of the textbook. Inverse circular and inverse circular functions of a real variable. Readers have already, we know that equation sin theta equal to x means that theta is an angle whose sine is x. The statement can also be written in the inverse way. By writing theta equal to sine inverse x and is read as theta is equal to sine inverse x and is read as theta is equal to sine inverse x and is read as theta is equal to sine inverse x. Thus the symbol sine inverse x is defined as an angle whose sine is x. Thus the symbol sine inverse x is defined as an angle whose sine is x. Now if sine theta equal to x, then theta is equal to sine inverse x. Putting the value of theta in 1, this is equation number 1, sine theta equal to x. Putting the value of theta in 1 and that of x in second respectively, we get sine of sine inverse x is equal to x. Putting the value of theta in 1 and that of x in second respectively, we get sine of sine inverse x equal to x and theta equal to sine inverse bracket sine theta. From 3 and 4 it follows that sine and sine inverse are two inverse operators which cancel each other. From 3 and 4 it follows that sine and sine inverse are two inverse operators which cancel each other. Theta equal to sine inverse sine theta. Similarly, cos inverse x, tangent inverse x, cot inverse x, secant inverse x and cosecant inverse x are defined as the inverse of cos x. Tangent x, cot x, secant x and cosecant x respectively. Journal values and principal value. principal value, the value of inverse trigonometric function which is least in magnitude. Principal value, the value of inverse trigonometric function which is least in magnitude out of all the possible values is called the principal value. Thus the value of sine inverse x, cos inverse x, tan inverse x, cosecant, cot inverse x, secant inverse x, cosecant inverse x, which are least in magnitude, are called their respective principal values. Thus the values of sine inverse x, cos inverse x, tangent inverse x, cot inverse x, secant inverse x and cosecant inverse x, which are least in magnitude, are called their respective principal values. The value of inverse trigonometric function which is least in magnitude, कम से कम हो जो मैग्नीट्यूड में, and all the possible values is called the principal values. यानी जितनी पॉसिबल वैल्यू हैं उसमें लिस्ट वैल्यू होगी उसको हम प्रिंसिपल वैल्यू कहेंगे. द वैल्यू ऑफ इनवर्स ट्रिग्नोमेट्रिक फंक्शन विच इज लिस्ट इन मैग्नीट्यूड out of all the possible values is called principal values. Thus the value of sine inverse x, cos inverse x, tan inverse x, cot inverse x, secant inverse x, cosecant inverse x, which are least in magnitude, are called their respective principal values. For example, consider the equation tangent theta equal to under root 3. Now tangent theta equal to under root 3 equal to tangent pi by 3. Therefore theta equal to pi by 3 plus pi by 3, where n is 0 or positive or negative integer. Theta equal to tan inverse under root 3 equal to pi by 3. The value pi plus pi by 3, 2 pi plus pi by 3 plus so on. Evidently tan inverse under root 3 is a multi-valued function. Evidently tan inverse under root 3 is a multi-valued function. The value which is least in magnitude, that is lies between minus pi by 2 and pi by 2, is called the principal value of tan inverse under root 3. Thus the principal value of tan inverse under root 3 is pi by 3. Principal value of tan inverse under root 3 is pi by 3. General values, if we take all possible values of theta whose sign is x, if we take general values, if we take all possible values of theta whose sign is x, then all such values are called general values of theta. If we take all possible values of theta whose sign is x, then all such values are called general values of theta is equal to sine inverse x. If theta is a least positive or negative angle, अगर थीटा क्या है, if theta is a least positive or negative angle whose sign is x, then the general value of sine inverse x is n pi plus minus 1 की power n theta, and that of cos inverse x equal to 2n pi plus minus theta. If theta is a least positive or negative angle, if theta is a least positive or negative angle whose sign is x, then the general value of sine inverse x is n pi plus minus 1 की power n theta, and that of cos inverse x is equal to 2n pi plus minus theta. If we take all possible values of theta whose sign is x, then all such values are called general values of theta equal to sin inverse x. If theta is a least positive or negative angle whose sign is x, then the general value of sin inverse x is n pi plus minus 1 की power n theta, and that of cos inverse x equal to 2n pi plus minus theta. The following table gives the principal values of 6 inverse circular functions. Functions y equal to sin inverse x, principal value range y lies between minus pi by 2 and less than equal to pi by 2, minus 1 less than equal to x less than equal to 1 domain. Y equal to cos inverse x, its domain is x lies minus 1 to 1 and range is 0 less than equal to y less than equal to pi, 0 pi. Principal values, these are table of principal values functions. Y equal to tan inverse x, principal value y की minus pi by 2 to pi by 2 and x lies between minus infinity to plus infinity. Y equal to cot inverse x, 0 less than y less than pi, minus infinity less than x less than infinity. Y equal to secant inverse x, 0 less than equal to y less than pi by 2, pi by 2 less than y less than equal to pi, where 1 less than equal to x less than infinity, minus infinity less than x less than equal to minus 1. Y equal to cosecant inverse x, minus pi by 2 less than equal to y less than 0, 0 less than y less than equal to pi by 2, when x lies minus infinity less than x less than equal to minus 1, 1 less than equal to x less than infinity. Notations, we choose to write the general value of the inverse circular functions by writing the first letter as capital and first letter as capital. Notation, we choose to write the general value of the inverse circular function by writing the first letter as capital and principal value with small letter. Principal value with small letter and general value by capital letter. For example, general value sin inverse x equal to n pi plus minus 1 की power n sin inverse x. General value cos inverse x is equal to 2n pi plus minus general value principal value cos inverse x. Tan inverse x equal to capital T tan inverse x equal to n pi plus tangent inverse x. Now relations between inverse functions. To prove that sin inverse x equal to cosecant inverse 1 by x, cos inverse x equal to secant inverse 1 by x, tan inverse x equal to cot inverse 1 by x. Second, cosecant inverse x sin inverse 1 by x, secant inverse x equal to cos inverse 1 by x, cot inverse x equal to tangent inverse 1 by x. Proof of 1, let sin inverse x equal to theta implies x equal to sin theta. Now cosecant theta equal to 1 by sin theta is equal to 1 by x implies theta equal to cosecant inverse 1 by x. Sin inverse x equal to cos inverse 1 by x. this relation we get. Let second, for the second, let cosecant inverse x equal to theta implies x equal to cosecant theta. Now sin theta is equal to 1 by cosecant theta is equal to 1 by x implies theta equal to sin inverse 1 by x. Therefore cosecant inverse x equal to sin inverse 1 by x. Readers, the proof of the result 3 and 4 on the similar lines. 3 and 4, first, second, third. We have proved first, second, 3, 4, 5, 6. These are on the similar lines. We can prove this. Third to 6 we can prove on the similar lines. To prove that sin inverse minus x equal to minus sin x, cos inverse minus x equal to pi minus cos inverse x, tangent inverse minus x equal to minus tangent inverse x, cot inverse minus x equal to minus cot inverse x, cosecant inverse minus x equal to minus cosecant inverse x, secant inverse minus x equal to pi minus secant inverse x. To prove these, let sin inverse minus x equal to 0, minus x equal to sin theta implies x equal to minus sin theta implies x equal to sin minus theta. Only principal values are taken in consideration. Which one? Footnote is about, anyway, you will only principal values are taken in consideration. This above footnotes is about this. It must have given star some. Minus theta implies minus theta is equal to sin inverse x implies theta equal to minus sin inverse x. Sin inverse minus x equal to minus sin inverse x. Results 3 and to 4, 3 to 5th can be proved on similar lines. Let cos inverse minus x equal to theta, then taking cos to right hand side, minus x equal to cos theta implies x equal to minus sin theta minus cos theta implies x equal to cos pi minus theta, क्योंकि cos pi minus theta equal to minus cos theta implies cos inverse x equal to pi minus theta implies theta equal to pi cos inverse x implies cos inverse minus x equal to pi minus cos inverse x. Similarly, we can prove that secant inverse minus x equal to pi minus secant inverse x. We can prove that secant inverse minus x equal to pi minus secant inverse x. To prove that sin inverse x plus cos inverse x is equal to pi by 2, tan inverse x plus cot inverse x equal to pi by 2, secant inverse x plus cosecant inverse x equal to pi by 2. Proof: let sin inverse x equal to theta implies x equal to sin theta. We know that cos pi by 2 minus theta equal to sin theta. Cos pi by 2 minus theta equal to x, or pi by 2 minus theta equal to cos inverse x implies pi by 2 minus sin inverse x equal to cos inverse x. Sin inverse x plus cos inverse x equal to pi by 2. Similarly, we can prove the results second and third. Second and third. But we have proved sin inverse x plus cos inverse x equal to pi by 2. हमने क्या किया इसमें, साइन इनवर्स एक्स इक्वल टू थीटा को एक्स निकाल लिए साइन थीटा में. अब यहाँ हम ट्रिग्नोमेट्री का यूज़ कर रहे हैं. वी नो डैट कॉस पाई बाई 2 माइनस थीटा, ये कॉस में जब 90 ऐड करते हैं या घटाते हैं तो साइन बन जाता है. और लेकिन साइन थीटा क्या एक्स है ऊपर से, तो अब कॉस को राइट हैंड साइड में ले जाओ. पाई बाई 2 माइनस थीटा कॉस इनवर्स एक्स. अब पाई बाई 2, अब साइन थीटा क्या है, साइन इनवर्स एक्स. लेट मानना है ना, लेट साइन इनवर्स एक्स इक्वल टू थीटा. अब थीटा की वैल्यू यहाँ पुट कर दी, पाई बाई 2 माइनस साइन इनवर्स एक्स इक्वल टू कॉस इनवर्स एक्स. देयरफॉर ये साइन इनवर्स एक्स प्लस कॉस इनवर्स एक्स पाई बाई 2 हो गया. देयरफॉर साइन इनवर्स एक्स प्लस कॉस इनवर्स एक्स इक्वल टू पाई बाई 2. सिमिलरली वी कैन प्रूव द रिजल्ट्स सेकेंड एंड थर्ड. इसी तरह हम रिजल्ट सेकेंड एंड थर्ड प्रूव कर सकते हैं. अब एग्जाम्पल 11.4.4 टू प्रूव डैट 1 tan इनवर्स एक्स प्लस tan इनवर्स वाई इक्वल टू tan इनवर्स एक्स प्लस वाई 1 माइनस एक्स वाई. ये प्लस के लिए, अगला माइनस के लिए है. फिर 3 है ये tan इनवर्स एक्स प्लस tan इनवर्स वाई प्लस tan इनवर्स जेड. जैसे हम ट्रिग्नोमेट्री में करते थे वही चीज़ है ये. tan इनवर्स एक्स प्लस वाई प्लस जेड माइनस एक्स वाई जेड 1 माइनस वाई जेड माइनस जेड एक्स माइनस एक्स वाई. तो एक का प्रूफ दिया है, अगले सेकंड को ऐसे कर सकते हैं. लेट tan इनवर्स एक्स को कैपिटल ए मान लो, इम्प्लाइज एक्स tan ए हो गया. इसी तरह tan इनवर्स वाई को भी मान लो, इम्प्लाइज वाई इक्वल टू tan v हो गया. वी नो डैट टेंजेंट ए प्लस बी इक्वल टू tan ए प्लस tan b 1 माइनस टेंजेंट ए टेंजेंट v. देयर एंड टेंजेंट ए प्लस बी इक्वल टू एक्स प्लस वाई. इनकी वैल्यू पुट की, टेंजेंट ए टेंजेंट बी 1 माइनस एक्स वाई इम्प्लाइज ए प्लस बी इक्वल टू tan इनवर्स एक्स प्लस वाई डिवाइड बाय 1 माइनस एक्स वाई. Putting the value of a and b from 1 and 2 in 3, we get tan inverse x plus tan inverse y equal tan inverse x plus y 1 minus xy. Similarly, we can prove result second. So, dear students, today we will finish the lecture here. And you will see this online lecture on college website www.bljscollege.com or on YouTube. Thank you. If there is any query or question, you may contact with pleasure. Thank you, students.